Okay, in this problem, I should say in this video, I'll be covering three problems. The first one deals with evaluating a piecewise function for given input values. Let me go to the next page. And then we're going to talk about rational functions where you've been given some conditions, vertical asymptotes, horizontal asymptotes, and x-intercepts, and you're supposed to identify an equation that has these asymptotes and x-intercept. And then finally, on the third problem, we're going to do the dietitian problem, which deals with how many servings of three different foods you're supposed to give in order to meet some dietary requirements. So let's go ahead and go back to the beginning here and we'll get started. So in the first problem here, it says h of x is equal, now it says negative 5x minus 18 for x less than negative 7. So for any number that's smaller than negative 7, like negative 8, negative 9, and so on, you're going to plug that input value into this piece here. For any value of x that's between negative 7 and 3, including negative 7 but not 3, your output is going to be 3. And then finally, your output is x plus 2 if x is greater or equal to 3. So if your input value is either 3 or bigger, you're going to use this piece here, x plus 2. All right, so let me erase my marks. And so let's go ahead and find h of negative 10. Now negative 10 is less than negative 7, so that would be this first piece. And so let's go ahead and make a shell. And let's plug in negative 10 for x. So let's see, that goes there. And so this would be 50 minus 18, which is, what's that, 32? And so for h of 0, now notice 0 would be in here between negative 7 and 3. And so our output is 3. That's all we need to put there. There's no x in this output. Our output's 3 no matter what our input is when we go from negative 7 to something that's less than 3. Okay, so h of 3, notice that would fall into this piece where x is greater or equal to 3. And so we're going to use x plus 2. And let's plug in an input of 3. And so our answer there is going to be 5. For h of 8, again, 8 would fall into this piece here because our input, or our x value, is greater than 3. 8 is greater than 3. And so again, it'll be like the one we just did, where it's going to be our input plus 2. Our input is 8. And so we're going to end up with 10 there. All right, let's move on to the next problem. So this deals with rational functions, functions that have fractions in them basically. So let me go ahead and give you the pieces here. We're supposed to find a rational function that satisfies the given conditions. So first of all, we need vertical asymptotes at x equals negative 4 and x equals 5. We need a horizontal asymptote at y equals 4/3, and we need an x-intercept of 8, 0. Now if you had this problem on the test, you would have like 4 choices for answers. And so the way I would encourage you to do a problem like this is look at each of the cases and then see if they meet the conditions that you're given here. It's a little bit harder to build it from scratch like I'm about to do. So for example, if you want vertical asymptotes of -4 at x equals -4 and x equals 5, remember vertical asymptotes are where your restricted values are. So if we're writing some function that has asymptotes of x equals -4 and x equals 5, then we would have factors of x plus 4 and x minus 5, so that our restricted values would be -4 and 5, which is where we have our vertical asymptotes. All right, so, and we could multiply this out in the denominator here. For now, I'm not going to do that. So next we need vertical or horizontal asymptotes of a horizontal asymptote of y equals 4/3. So normally, there's three cases with horizontal asymptotes. We know if the rational expression is bottom heavy, that means the degree in the denominator is bigger, then we have a horizontal asymptote at y equals 0. If the degree of the numerator is greater, we know we have no horizontal asymptotes. And so this would be the case that I called the balanced case, where the degree of the numerator and denominator are the same. So now maybe I should go ahead and write the denominator here. It would be x squared minus x minus 20. So this would be the balance case, so I need an x squared in the numerator, and our coefficients would need to be 4 and 3. So basically, it would be 3 times what we already have in the denominator there. In the numerator, so basically this would be 3x squared minus 3x minus 60 in the denominator. If it's not in factored form, if it's in factored form, it would look like that, this part here. In the numerator, again, our degree should be the same. Notice our degree is 2 in the denominator, it's 2 in the numerator, so we're balanced, and we have 4/3 as our coefficients of the leading terms. And so we do get y equals 4/3 for a horizontal asymptote. Now the other issue we have here is we need to have an x-intercept of 8, 0. So basically, if we let y be 0, or f of x equals 0, this fraction needs to equal 0. And it occurs when the numerator is equal to 0. We know a fraction equals 0 when the numerator equals 0. And so if I want to set my numerator equal to 0 and get x equals 8, I got to think a little bit here. This is what I was talking about when I said it's a little bit harder to build than it is to actually look at 4 possible answers and test those to see that they meet these conditions. So the way to do that, just to play around with it a little bit, let's see, what we would need to do is, let's see, this would be plus, let's see, 4 times 8 is 32, and this would be an x. So basically what I've done is you could factor out a 4x, and it would be x plus 8 inside here. And actually, this should be a minus. So this is a minus. And so now you can see we have 4x times x minus 8. Which values of x cause our numerator to be 0? Well, if either x equals 0, which means 0, 0 is an x-intercept, or if x equals 8, because 8 minus 8 would be 0. So if x equals 8, then that would be the other x-intercept. So if you wrote it in factored form, well, actually you could write it both ways. It could be written like this, Or if you write it in factored form, you can see the different factors and the different parts. So let me just close this way. So because notice -4 and 5 are restricted values, we have vertical asymptotes at -4 and 5. Notice these are both degree 2, and so we're balanced here, and so the horizontal asymptote would be the quotient of the two leading terms, or I should say the leading coefficients, so 4/3 or y equals 4/3. And then finally, if you set your numerator equal to 0, I should say if y equals 0, if we put 0 here, then this fraction only equals 0 when the numerator is 0. And you can see because x minus 8 is a factor, that x equals 8 is going to be one of your x-intercepts. And so this function meets all the conditions. Again, on the test, you'll be given a function like this. It may or may not be factored, and then you can check to see that it meets all the conditions. All right, let's move on to the last problem. So this is what I would call the dietitian problem. And so I didn't write down the whole problem, but I wrote down the facts. So basically, we need to plan a meal for 900 calories, 60 grams of protein, and 200 milligrams of vitamin C. And we have 3 different foods to choose from, and we're supposed to figure out how many servings of each we're supposed to use. So first of all, we know that we're going to let x be the number of servings of steak, and we're told that a 3-ounce serving of steak has 300 calories, 20 grams of protein, and no vitamin C. And then secondly, we're going to let this be y. It represents the number of baked potatoes. 1 baked potato has 100 calories, 5 grams of protein, and 20 milligrams of vitamin C. And then finally, z is going to be our number of servings of Brussels sprouts. Ooh, that's one of my least favorite foods. Anyway, so Brussels sprouts have 50 calories. I should say the number of servings, I should say 1 serving, which I forget how many grams it was. But anyway, I'll also say 1 serving of Brussels sprouts is 50 calories, which also has 5 grams of protein and 100 milligrams of vitamin C. Okay, so basically, now we can set up our equations. So if we need to get 900 calories out of our food, notice, so this will be our step 1 here. So for each serving of steak, we're going to get 300 calories. So we need this first equation to represent all the calories. So for example, if there's 2 servings of steak, if x equals 2, that means we're getting 600 calories from the steak. That's the idea. So how many calories do we get from y baked potatoes? Well, it's 100 calories for each one. So if there were 3 baked potatoes, it'd be 3 times 100. So it's 100y. And the number of calories in z servings of Brussels sprouts is going to be 50 times z. And so we need that to equal 900 calories. So next we need 60 grams of protein. Well, for the steak, we're going to get 20 grams of protein for each serving. And for the potato, we're going to get 5 grams of protein for each baked potato, where there's y baked potatoes. And then 5z represents the number of grams of protein we're going to get for z servings of Brussels sprouts. And we need that to total 60. We're supposed to have from this meal, we're supposed to get 60 grams of protein. You can do the same thing for vitamin C. Notice there are you don't get any milligrams of vitamin C from the steak. We're getting 20 milligrams for each baked potato, or each serving of baked potato. and 100 milligrams of vitamin C for each serving of Brussels sprouts. And we need that to add up to 240. And so first of all, we had to find an equation. This is our equation. So now at this point, you could use matrices where we did Gaussian elimination with back substitution. I think because of the fact that I have a 200 here, I don't know, I guess I could have switched these two rows. I just, when I look at this, I see this as being easier to solve just using regular elimination, because I'm looking at that 20x, and I know if I multiply that by something, I can get a minus 300x. And I'll get rid of the x, and that means I'll get an equation in y and z. And I already have an equation in y and z. So remember, when we're solving systems of equations using elimination, our first goal is to get two equations in the same two variables. And so we're going to get two equations in y and z. We already have one. And we're going to use these two to eliminate x here and get another equation in y and z. So that's the idea. So I'm going to go ahead and call these equations 1, 2, and 3. And now let's go ahead and do step 2 here. Again, getting two equations in the same two variables using the system in step 1. So I'm going to go ahead and write down equation 1. And it turns out that 15 times 20 is 300. So I need to multiply by negative 15 to get negative 300. Negative 15 times equation 2, we're going to get negative 300x minus 75y, and 15 times 5 is 75, and then this will be minus 75z, and negative 15 times 60 is actually negative 900. Excuse me. So now let's go ahead and add these together, and notice again our x cancels out, and we get 25y minus 25z equals 0. And so let's call this equation 4, and now we can take this equation with our equation 3, and so now we have two equations in the same two variables, and we can use those to solve for y and z. So let's go ahead and do that. So you can see that it looks like it's going to be easier to eliminate z. In fact, 4 times negative 25 would be negative 100. What I'm trying to do is get opposites here. And so I'm going to rewrite equation 3, and I'm going to multiply equation 4 by 4. And so I get 100y. 4 times 25 is 100. Minus 100z equals 0. So now when I add these equations together, I get 120y equals 240, and you can see that y is 2. Now don't forget where we are and what we're trying to do here. We're solving this system of two equations in the same two variables. So let's finish solving this system. Now, let's see. Keep in mind, we can go back and use this equation here that we started with. And for me, I figured that was the easiest one to work with, so that's the one I used next. And so 25y minus 25z equals 0. We're using equation 4, and we're plugging in for y. So we'll get 50 minus 25z equals 0. And so I end up with 50 equals 25z, which means z is 2. All right, so we have solved this system of two equations and two variables, same two variables. We've solved for y, and we've solved for z. The only thing we have left is x. So what we want to do is go back to one of the original equations that has x, y, and z in it, Notice this equation here is probably the easiest one to work with. I don't think I would choose that one. And so I'm going to go ahead and write down, last step here, we're going to write down equation 2, and we're going to plug in 2 for y and for z. And so we have 20x plus 10 plus 10, or 20x plus 20 is equal to 60. Excuse me, so we'll subtract 20 on both sides, we get 20x equals 40, and so x equals 2. And so it turns out we're going to have 2 servings of each. So you could say 2 servings of steak, 2 servings or 2 baked potatoes, and 2 servings of Brussels sprouts. I'm just going to say 2 servings of each, and that's the end of this video.